6.4, solving absolute value equations. Let's review what absolute value means. Remember that absolute value is the distance a value is from zero. So let's go ahead and write that down, that absolute value is the distance a number is from zero. So the distance a number is from zero. Some examples of absolute value would be distance, anything involving distance. If we are traveling south, let's say, that's technically a negative value if we're going south, but we wouldn't say we're going negative 200 miles to Florida. We would say that we're going south 200 miles to Florida. So that's an example of absolute value. Because it's a distance, it's always positive. So down here, absolute value equations have a set of straight bars around a variable expression. So if you see here, here are the absolute value bars that signify absolute value. And then here's another example where the absolute value bars are around an expression 2x minus 3. All right, an example that is not an absolute value equation is here. And the reason that this is not an absolute value equation is because the variable is not inside of the absolute value bars. Notice here in these two examples, the variable is. So in order for it to be an absolute value equation, the variable has to be inside of the absolute value bars. Oh, you know what? I went ahead. So let's go ahead and let's scroll down. So let's talk about solving absolute value equations. Remember that if here I'm asking you what is the absolute value of 10, I would say that the absolute value of 10 is 10. It's 10 units away from 0. And likewise, the absolute value of negative 10 is also 10 units away from 0. So here, the solution to what number, this is asking me what number is 10 units away from 0. X could be either positive 10 or it could be negative 10. Either answer. And what you'll notice is that we're going to have two solutions for absolute value. So let's go ahead and let's start solving some absolute value equations. When you solve an absolute value equation, there's 4 steps you really want to remember to do. You want to always isolate the absolute value. That means get it by itself. Then you're going to break the equation into 2 separate equations that no longer have the absolute value bars. Then you're going to solve both equations independently, and then you always want to check your solution to make sure you did it correctly. So let's go ahead and let's look at number 1. Number 1 says the absolute value of x minus 3 is 7. The absolute value bars are isolated. That means it's the only thing on one side of the equation, which in this case it is. So now I can go ahead and break this into 2 separate equations. I'm going to have x minus 3 equals 7. And then I'm also going to have an x minus 3 equals a negative 7. Notice how I changed the solution on the right. One's positive, one's negative. All right, so now I'm going to go ahead and solve each equation independently. Add 3 to both sides. X equals 11. Oops, I mean 10. What am I thinking? Over here, add 3 to both sides. And x is going to equal negative 4. Now it can't equal both of these at the same time, so we always say it's going to equal one or the other. And then your solution would be that x equals 10 or it equals negative 4. Let's go ahead and look at the next example, number 2. Again, the absolute value is isolated. It's the only thing on the left side of the equation, so that's good. Now we're going to go ahead and break it into 2 separate equations. The first equation is x plus 1 equals 6. And the second equation is x plus 1 equals negative 6. We're going to go ahead and solve each of those independently. Subtract 1 from both sides. X equals 5. Over here, subtract 1 from both sides. X equals negative 7. Again, it can't equal these at the same time, so we say it's one or the other. Now in the last example, we didn't check our answer, so let's go ahead and check our answer in this example. So x plus 1 equals 6. I'm going to take the original problem and check 5, the solution 5 first. So really I'm saying is 5 plus 1, its absolute value, equal to positive 6? Well, the absolute value of 6 is actually 6. So 6 does equal 6, and that's a true statement. Now I want to go ahead and now check negative 7. So if I plug in negative 7 for x, I want to know, will that equal 6? So the absolute value of negative 7 plus 1, which is the absolute value of negative 6, and the absolute value of negative 6 is 6, so 6 does equal 6. So both of those solutions work. All right, let's go over to the back page for some more practice. All right, so number 3. X plus 5 equals negative 2. Again, the absolute value is isolated, so we're going to break it into two problems. X plus 5 equals, oh, you know what? I'm going to stop. An absolute value is never going to equal a negative number. Notice here, let me erase this for a second. Notice I have my absolute value isolated, and I'm saying it equals a negative number. That is not possible. So in this example, you don't have to do any math. The answer is simply that there is no solution. All right, let's go ahead and look at number 4. Notice that in number 4, the absolute value is not isolated. I have a 2 on the outside. I need to get rid of that 2 before I can split my equation up into 2. So in order to get rid of this 2, we're going to divide both sides by 2. So the 2 goes away, and we're left with x plus 1, the absolute value of that, equals 4. Now that my absolute value is isolated, now I can break it into two equations. X plus 1 equals 4, and x plus 1 equals negative 4. I can solve these individually, subtract 1 from both sides. X is going to equal 3, or subtract 1 from both sides. X will equal negative 5. So our solution is that x will equal 3 or x will equal negative 5. All right, let's go ahead and scroll down and do some more practice. In number 5, again notice that the absolute value is not isolated. There is a plus 3 on the outside that we have to get rid of. So to do that, because we're adding 3, we're going to subtract 3 from both sides of the equation. When we do that, we're left with 2x minus 5 equals 6. Now that the absolute value is isolated, break it into two problems. 2x minus 5 equals 6, and 2x minus 5 equals negative 6. From here, solve your two equations, add 5 to both sides. We get 2x equals 11. Divide both sides by 2, so x equals 11 over 2. Now go ahead and solve your other equation. Add 5 to both sides. 2x equals negative 1. Divide both sides by 2, and x will equal negative 1/2. Again, you can't equal both of these at the same time, so it's one or the other. All right, let's go ahead and look at number 6. If you feel like challenging yourself, hit pause, try the problem on your own, then hit play and see if you did it correctly. All right, so here in this example, I've got a couple things on the outside of my absolute value bars. I have a plus 3, and I'm multiplying by 2. Remember, you always get rid of addition and subtraction first. So I'm going to subtract 3 from both sides of my equation, and we're going to get 2 times the absolute value of 5x plus 1 equals 12. Then I'm going to divide both sides by 2 to get rid of that 2. So I'm left with 5x plus 1, the absolute value of that, equals 6. Again, now that the absolute value is isolated, now I can break it into my two equations. I have 5x plus 1 equals 6, and 5x plus 1 equals negative 6. I'm going to go ahead and solve those individually. 5x equals 5. Divide both sides by 5. X equals 1. I'm going to solve the other one. Subtract 1 from both sides. 5x equals negative 7. Divide both sides by 5. x equals negative 7/5. So again, it's one or the other. That whole thing is the answer. All right, let's scroll down and do number 7 and number 8. All right, number 7, again, if you feel like challenging yourself, hit pause, try the problem, then hit play to see if you did it correctly. All right, so you're going to add 8 to both sides. And when you do that, you're going to get 2x minus 4 in absolute value bars equals 12. Now we can split it into two equations. 2x minus 4 equals 12, and 2x minus 4 equals negative 12. Solve the two problems. Add 4, add 4. 2x equals 16. Divide by 2, divide by 2. X equals 8. Go ahead and solve the other problem, the other equation. Add 4, add 4. 2x equals negative 8. Divide by 2, divide by 2. X equals negative 4. Again, it's one answer or the other. All right, last example. Number 8. X minus 1/2 equals 5/2. This problem is no different than the ones that we've been doing so far. A lot of times when people see fractions, it's intimidating and they shut down and they think, oh my gosh, this problem is different. How am I going to do this? But it's not. So notice again that the absolute value is isolated. So I can go ahead and break my problem into two equations. I'm going to have x minus 1/2 equals 5/2. And x minus 1/2 equals negative 5/2. So I'm going to go ahead and solve both equations. I'm subtracting a fraction, so in order to get rid of that, I'm going to add it. And I'm going to do that on both sides of my equation. When I do that, I get x equals 5/2 plus 1/2 is 6/2, which simplifies to 3. So x equals 3. Do the same thing over here. I'm subtracting a half, so the inverse would be to add 1/2. And I'm going to do that to both sides of my equation. And x is going to equal negative 5/2 plus 1/2 is negative 4/2, which simplifies to negative 2. So our answer is that x equals 3 or x equals negative 2. All right, that is all there is for the notes for today. Go ahead, you can turn off your iPad if you're using an iPad or your phone, or if you're on your computer. Go ahead, put that away. Come see me for your homework, and it is due tomorrow.